A population of zebras can be represented by the function y equals 5x plus 12, where x represents the number of years passed and y represents the population. So what does that actually mean, y equals 5x plus 12? It's the linear function. Let's interpret the different parts. They're the different parameters of this function. Our first one that we have is 5. That is the slope of this function. The slope tells us by how much is this function growing or reducing or decreasing. Since it is a positive slope, we have a function that is growing, and we can see that. Since the slope is 5/1, this means that for every 1 year that goes by, or 1 is the change in x, there will be a growth of 5 units of population in zebras, since the top number, the numerator, represents the change in y. Then our next parameter is this 12 over here, and that is the y-intercept. So when x equals 0, y equals 12, that means that when no time has passed, the original population of zebras is 12 units. Let's look at an exponential example. The amount of bacteria in a petri dish after x amount of time can be represented by the function y equals 1/2 times 3 to the x plus 1/5. Our first parameter in an exponential function that we want to take a look at is the base. The base is 3, which tells us that for every change in x, this function is tripling itself. The original amount is tripling itself. Then we also have a vertical translation of positive 1/5. That means that every single y value is added, gets 1/5 added to it. That's why it's called a vertical translation, because it shifts the graph, in this case, up by 1/5, since it's a positive 1/5. And then finally, our last parameter that we want to look at is the y-intercept. Now, if we didn't have a vertical translation, if this were the only part of this exponential function, then our our y-intercept would just be this first value right over here, the original amount, 1/2. But since we do have a vertical translation, that original amount is moved up by 1/5 as well. So our y-intercept is actually going to be the original amount, 1/2, plus 1/5. So if we add those together, it gives us a y-intercept, or a real original amount, of 7/10. So here we have some original population being tripled for exponentially, and the total value is being shifted up by 1/5, is being increased. Every single value point is being increased by 1/5.